Okay, here's the recording in progress. So we just have one last section, section 10.5. Okay, so we're doing the parabola, the ellipse, and the hyperbola. Okay, so what you want to put on your formula sheet for the parabola, there's four basic parabolas. One that goes up, down, right, and left. Focus is always on the inside, directrix on the outside. Okay, so P is the focal distance. It's the distance away from the focus to the vertex and also the vertex to the directrix. So here, parabola opening up, x squared equals 4py. An example is y equals x squared. Okay, P is the focal distance, so here's 0p, y equals negative p. Turn the whole picture 180 degrees over, x squared equals negative 4py. Focus is 0, negative p, directrix is y equals p. Parabola opening to the right, y squared equals 4px. Okay, looks like so. Focus again on the inside, p0 is the focus, directrix x equals negative p. And y squared equals negative 4px. It's a parabola opening to the left. Focus is at negative p0, directrix is x equals p. Notice for the directrix, it's a line. It's either a horizontal or vertical line. Horizontal lines have equation y equals a constant. Vertical lines have equation x equals a constant. You need to put the x or y equals. You won't get full credit. If you just put directrix is 3, you need to say x equals 3 or y equals 3, as the case may be. Okay. All right, so I'll try to do as much as I can with the parabolas and maybe sneak in some ellipses also. Okay, so number one, x squared equals 6y. So I want to force this to look like 4py. Okay, first thing I notice is x squared equals 6y. That looks like this. So it's a parabola opening up. So I draw a little U shape, meaning it's opening up. Okay, you want to write this as 4 times p equals 6. So 4 times what number gives me 6? Well, it's 6 over 4 or 3 halves. Right, x squared equals 4 times 3 halves y. 4 times 3 halves is 6. So my p is 3 halves. Right, I know it's opening up. So here we go. Focus is at 0, 3 halves. Vertex is at the origin. Directrix is y equals negative 3 halves. And you say, is the vertex ever outside of 0, 0? Well, sure. You might have the translation like this, the usual, right? You move left, right, up, or down, as the case may be. Okay, here's number 3. 2x equals negative y squared. All right, it's y squared equals negative 2x. So it's squared in y, not in x, and there's a negative. So squared in y, not in x, and a negative. So it's this one. So I know it's going to open to the left. So this tiny little backward C tells me I'm going to graph it this way. So write this as negative 4px. So negative 4 times what number is negative 2? Well, a half. Okay, so my p is a half. So I go half a unit to the left, half a unit to the right. So the focus is negative 1/2, comma 0. The directrix, I go 1 unit to the right, but remember the directrix is not just a point, it's an entire line. So the directrix is x equals a half. So you essentially just pick the right one. Is it this type, this type, this type, this type? Does it look like x squared equals 4py, or x squared equals negative 4py, or y squared equals 4px, or y squared equals negative 4px? You just pick the right one. Okay, then 7 star is not quite the same as what I've got, but it's similar. You can work it out in a similar fashion, I'm sure. Okay, so for this one, I have to do some completing a square. Okay, so y squared plus 2y plus 12x plus 25 equals 0. Throw these two guys over, they become negative. Negative 12x minus 25. Now I complete the square. Okay, half the coefficient of y and then square it. So half of 2 is 1. 1 squared is 1. So I add 1 to both sides. Factor y plus 1 squared equals negative 12x minus 24. Okay, factor out the negative 12. Y plus 1 squared equals negative 12 times x plus 2. right? So this tells me a translation of 2 left and 1 down. Is that right? Which means the vertex is going to be -2, -1. For both of these original ones, the vertex is the origin, right? It'll only be off the origin when you have something like this going on. All right, now this -12, I want to force it to look like -4 times something, well, -4 times 3. Okay, so once again, it's squared in y, not an x, and there's a negative. Squared in y, not an x, and there's a negative. So I know it's going to open to the left once again. And the p is 3. All right, so what's my vertex? The translation is 2 to the left, 1 down. So the vertex is -2, -1. -2, -1. Okay, the p is 3. So I go 1, 2, 3. Focus is -5, -1. And I go 1, 2, 3 to the right. But again, it's not just a single point. I draw an entire line. So what is this vertical line? X equals 1. Okay, so there it is. So in general, they're going to ask you for the vertex, focus, directrix, and the sketch. Show you the directions, right? Find the vertex, focus, and directrix, and sketch the graph. Okay. Okay, jumping down to 31 now. Find the equation of the conic section. It's parabola, ellipse, hyperbola, or circle, but we don't have to worry about circles now because we've already done circles. All right, so 31. Vertex is the origin. That's best case scenario. Focus is 1, 0. Okay, so vertex is the origin. Excuse me. Focus 1, 0. All right, this is the focus. Focus is always inside, so I know it opens to the right. The vertex is here. Focus is always on the inside. So opening to the right means y squared equals 4px. Okay. Put all these guys directly on your cheat sheet. I'll let you do that. Okay. I am giving you a heads up though. If we were meeting face to face, I'd make you memorize it. The last time I taught this class, the students had to memorize it. That was pre-pandemic. So anyway. Well, that was then and this is now, right? Let's see, where am I? So p is 1. Y squared equals 4px. So how do you know p is 1? Well, p is the distance from the vertex to the focus. And yes, there is a directrix over here. They don't ask us to do that. They just want the equation. So just put a 1 in here. So the equation is simply y squared equals 4x. That's all there is to it. All right, then 33. They're giving me the focus is -4, 0, and the directrix is x equals 2. So focus, -4, 0, directrix is x equals 2. Now I know the vertex is halfway between them. So what's halfway between -4 and 2? You just count over 1, 2, 3, 4, 5, 6. So I go 3 over, and this is my vertex. Vertex is -1, 0. And once again, it's opening to the left. So I know it's going to be this variation. Y squared equals -4px if the origin was the vertex. I know it's shifted 1 unit left at -1, 0, but just for analysis, I know focus is here, directrix is here. I go halfway between -4, 0 and 2, 0. That's -1, 0. So I'm going to go y squared equals -4px. I know the p is 3. Just count 1, 2, 3. Distance from vertex to the focus, or distance from the vertex to the directrix, also 1, 2, 3. So p is 3. So if the vertex were at the origin, y squared equals -12x. Now I translate. Translate meaning move. Vertex is -1, 0, so I shift 1 to the left, which means change x to x plus 1. So here's my final equation. Y squared equals -12 parentheses x plus 1. So that's what I have for that one. All right. So I'll show you this, another compact version for the parabola. It's sort of what I have over here, but I have less information here. Something quick and dirty to see all the parabolas. X squared equals 4py. Looks like this. X squared equals negative 4py. Looks like this. Y squared equals 4px. Like this. Y squared equals negative 4px. Looks like this. Okay. I'll get you the ellipse and the hyperbola again in just a moment. Okay, so let me go back to number 5. Yeah. X plus 2 squared equals 8 times y minus 3. Okay, I want to write this as 4p. So 4 times what number is 8? Well, 2. 4 times 2. Okay, so I see it's squared in x, not in y, and positive. So that tells me this parabola is opening up, U-shape. And the translation is 2 to the left and 3 up, right? X plus 2 means 2 left, y minus 3 means 3 up. So the vertex is negative 2, 3. Right? I know it's U-shape. Focus is 2 up, so negative 2, 5. Directrix is 2 down, y equals 1. Okay, so there we go. Okay, then I'm going to show you 35 star, which is a variation of our 35. Parabola, they give you the vertex, a horizontal axis, and passing through negative 15, 2. Okay, so this was in the previous edition, but it's similar. Okay, vertical axis. Axis is like axis of symmetry. So if you have a vertical axis of symmetry, it's going to either be up or down. So vertical axis of symmetry. Horizontal axis of symmetry. Okay. Vertical axis of symmetry goes through the vertex and, well, you get a mirror image, right? A reflection on the axis of symmetry. So vertical axis of symmetry means it's parabola is either opening up or down. Horizontal axis of symmetry, either left or right. So in this particular case, it says a vertical axis. The vertex, all right, so if the vertex were at the origin, I would say x squared equals 4py. But since the vertex is 2, 3, I change x to x minus 2. I change y to y minus 3. So x minus 2 squared equals 4p y minus 3. Picture looks something like this. Here's 2, 3, vertex, and I know the graph passes through 1, 5. So here's 1, 5. It's going to look something like this. Okay, so how do I find the p? I plug in. So at this stage, because I know the vertex is 2, 3, I'm going to go x squared equals 4py is at the origin, but since we're at 2, 3, x becomes x minus 2 squared, and 4p becomes y minus 3. And now, since I know the graph passes through 1, 5, I plug in 1 right here, 5 right here, and then try to solve for p. And that'll give it to me. Okay, so put a 1 here. 1 minus 2 squared equals 4p, 5 minus 3. And just do the algebra. So 1 minus 2 is negative 1. Squared, you get 1. 4 times p times 2. 8p is 1, so p is 1/8. Okay, plug in 1/8 back over here. 4 times 1/8 is 1/2. So here's my final answer. X minus 2 squared equals 1/2 y minus 3. Okay, so that pretty much does it for the parabolas. Yeah, I strongly advise you to put sample problems on your cheat sheet also. So put all these formulas, but you're allowed to put sample problems. So if I give you a problem on the test, say, hey, that looks exactly like this, then you just kind of adjust accordingly, right? All right, so that's the parabola. And I think I've done all the parabola ones I was going to do. Double check my work, but if not, I can always show you more next time. Now I'll get started on the ellipse. So I showed you last time on the ellipse. I've pretty much done all the parabolas I want to show you. So for an ellipse, you don't have to write this down, but just curiosity. An ellipse is a set of points in a plane, the sum of whose distances from two fixed points, F1 and F2, is a constant. Okay, so if you take two foci, one focus, two foci, and you have a certain distance, okay, imagine you have a string here, and you try to keep it taut and move that string here and down here, you draw yourself an ellipse. Okay. So the distance from here to here plus the distance from here to here is constant. Okay, so let's say this distance is 10, and when I go that plus that, it's 10, and that plus that is 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 10, and so on. Okay. So you get a constant distance. They go over the derivation. You can look at it or not. I'm not going to go over it. Okay, I'll just tell you the result. So on page 677, the ellipse looks like x squared over a squared plus y squared over b squared equals 1, or x squared over b squared plus y squared over a squared equals 1. It just depends on which is the larger number. Okay. If the larger number is under the x, graph goes like this. If the larger number is under the y, graph goes like this. You do have a Pythagorean relation for the ellipse. This is true, but I like to write it as a squared equals b squared plus c squared, which is not the Pythagorean theorem that you're used to, but a is the largest number. Okay. C is the focal distance. It's always along the major axis. Major axis is the larger, minor axis is the smaller. Okay. The two foci are always along the major axis. So we look over here, major, minor, bigger, smaller. The foci are always on the major axis. And the relation we have is a squared equals b squared plus c squared. Show you my version. For an ellipse. Okay, so bulging horizontally, A, B, C, a squared equals b squared plus c squared for the ellipse. So the equation goes x squared over a squared plus y squared over b squared equals 1. Put that on your formula sheet. If you just turn the picture 90 degrees, it looks like this. So this is A, larger number vertically, horizontally smaller, and C is somewhere here. Then we're going to say x squared over b squared plus y squared over a squared equals 1. But we're still going to say a squared equals b squared plus c squared. So A is the distance from the center to the endpoints of the major axis. This is the minor axis. So the number underneath the x and y tells you how far you go left and right versus up and down. Okay. In general, for an ellipse, the A and B are different. If A and B are equal, then you have a circle. So if it goes, let's say x squared over 25 plus y squared over 25 equals 1, then you have a circle. But in general, these are going to be different numbers. Okay, so A, or the number under the x, I should say, the number under the x, whether it's A or B, that's how much you go left and right. The number under the y is how much you go up or down. Okay, put down vertices. Vertices, plural, vertex. Those are the endpoints of the major axis. So the major axis, the larger axis, endpoints are vertices. Endpoints are vertices. So what do you call the endpoints of the minor axis? You don't call it anything. They're just endpoints of the minor axis. And these two are the foci, F-O-C-I, one focus, two foci for an ellipse. Okay, and then I'm not sure how much I'll get for the hyperbola, but for hyperbola, notice these equations look almost the same, except for there's a minus. So for the hyperbola, just take these equations, put a minus sign, that gives you a hyperbola. But otherwise, everything else is the same. And that tells you whether or not you have an hyperbola or an ellipse, because for the squared stuff, for the ellipse, you only have plus symbols. For hyperbola, you have a minus symbol. Okay, so let me try to start some ellipse. Problem 11. X squared over 2 plus y squared over 4 equals 1. Okay, the number under the y is bigger than the number under the x. That tells me it's bulging this direction. If the number under the x is bigger than the number under the y, it's bulging horizontally. And I'll show you examples of that. Okay, take the square root of each of these guys. So A is 2, B is radical 2, which is about 1.4. So from the center, I go 2 up and down, 1, 2, 1, 2. So my vertices are V1 is 0, 2, V2 is 0, negative 2. Left and right, I go radical 2, or about 1.4. So negative radical 2, 0, radical 2, 0. And are these given any names? No, there's no names for them, just endpoints of the minor axis. And then find the foci. Use a squared equals b squared plus c squared. A squared is 4, b squared is 2, c squared is 2, therefore c is radical 2. Don't need plus or minus. So that's also about 1.4. Okay, so along the major axis, which in this case is vertical, I go about 1.4 up, 1.4 down. Okay, so here are my two foci. F1 is 0, radical 2, and F2 is 0, negative radical 2. So here is my first example of an ellipse. Okay. All right. Okay. 13. X squared plus 9y squared equals 9. By formula, I'm supposed to have a 1 here. Where'd it go? Oh, anyway, yeah, I'm supposed to have a 1 on this side. X squared over a squared plus y squared over b squared equals 1. Or x squared over b squared plus y squared over a squared equals 1. Okay. Right now it's a 9. So I just divide both sides by 9. So I get x squared over 9 plus y squared over 1 equals 1. Okay, this time the number under the x is bigger than the number under the y, so I know it's bulging horizontally. So again, which way is the ellipse bulging? This away or this away? You look at the numbers here. 9, 1, 9 is bigger. So X direction, it's bulging. The one I just showed you was the other way around, right? The number under the Y is bigger than the number under the X, so it's bulging this way. Okay. Take the square root of each of these. A is 3, B is 1. So from the origin, I go 3 left and right. 1, 2, 3, 1, 2, 3. The B is 1. I only go 1 up and down, 0, 1, 0, negative 1. So there's the graph. Vertices are the endpoints of the major axis, larger axis. So vertex 1 is negative 3, 0. Vertex 2 is 3, 0. This is 0, 1, and 0, negative 1, but they're not called anything. They're just the endpoints of the minor axis. And now find the foci. The foci are along the major axis. So I use a squared equals b squared plus c squared for the ellipse. Put that formula on your formula sheet. So a squared is 9, b squared is 1. That should be pretty easy. C squared is 8. C is the square root of 8, which is about 2 radical 2. But its decimal approximation is 2.8. So I go 1, 2.8 all the way to the right. So it's very close to the vertex. And 1, 2.8 on this side. So my two foci are negative 2 radical 2 comma 0 and positive 2 radical 2 comma 0. And there we go. Okay. All right, I was just going to show you one more and then I'll be done for the day. I can do more ellipses tomorrow. So I've accomplished giving you pretty much the whole parabola section and maybe half the ellipse. So tomorrow, finish the ellipse and the hyperbola. Thursday review or anything I don't quite finish. Thursday and then Friday's the next test. Okay, a little bit harder. 15. They give me 9x squared minus 18x plus 4y squared equals 27. So that looks like completing the square again. Here's what to do. First, factor out the 9, x squared minus 2x. If there was a y term here, like 4y squared, I don't know, plus 6y, I would complete the square here also, but I don't have to because there's no y term. There is an x squared and an x term. Now, complete the square here. Half of negative 2, negative 1. Square it, 1. But when I put plus 1, it's really plus 9 because I'm distributing the 9. So in red, I balanced the equation by adding 1 here and adding 9 here. So that gives me 36. This factors into 9 parentheses x minus 1 squared. Okay, so 9 times x minus 1 squared plus 4y squared equals 36. The standard form for the ellipse, I'm supposed to have a 1. So I divide both sides by 36. Divide that by 36, divide that by 36, divide that by 36. So that gives me x minus 1 squared over 4 plus y squared over 9 equals 1. Okay, so this is a shift of 1 unit to the right. So my center is not 0, 0. My center is 1, 0. Which way is the graph bulging? Under the x is 4. Under the y is 9. This is bigger, so I know it's going to go this way. If this number is bigger than this number, it's going to bulge the other way. So take the square root of each of these guys. Square root of 4 is 2, that's B. Square root of 9 is 3, that's A. Find C, the focal distance, by using A squared equals B squared plus C squared. So put a 9 here, 4 here, C squared. C squared is 5. C is radical 5, which is about 2.2. So here I go. The center is 1, 0. Okay. A is 3, so up and down 3 units. 1, 2, 3. Vertex 1, 1, 3. Go down 1, 2, 3. Vertex 2 is 1, negative 3. Go 2 to the left. 2 to the right. 2 to the left is -1, 0. 2 to the right, 3, 0. Those are the endpoints of the minor axis, which don't have a name except endpoints of the minor axis. And then I go 2.2 up and down to get the foci. So 1, 2, and a little bit. And I go down 1, 2, and a little bit. So here's focus 1, 1 comma radical 5. Focus 2, 1 comma negative radical 5. So there we go. All right, and that's as much as I was going to do today. So for this last section, I think I've shown you all the parabolas. I've done some ellipses. Tomorrow I'll do some more ellipses and the hyperbolas. And if I don't finish, I still have Thursday. Otherwise, Thursday for questions and answers. And then Friday, be ready for the next test, of course. So then we mark this off over here. So tests this Friday, the 29th, exam 4. Okay. All right, let me stop the share and see if anybody has any questions. Check the chat. Nothing in the chat. Okay, anything else, please? Otherwise, we're done for the day. All right, have a good day, everybody, and we'll see you next time. Okay. All right, bye, everyone.
Take care, Professor. Thank you.
Thank you.